Hello class, I'm just going to walk through a few examples covered in this week's material for calculating the margin of error and a confidence interval. Up here at the top we have our formulas. This is to calculate a margin of error. This is to calculate a sample size based on a given margin of error. And here's our z-values for different confidence levels. So this information is just given to us. It's constant. It's not going to change. It's not something you have to calculate. If you're looking for a 90% confidence level, you're always going to use 1.645 for z, etc. So let's walk through these examples. You want to rent an unfurnished one-bedroom apartment in Durham, North Carolina next year. The mean monthly rent for a random sample of 60 apartments, there's my sample size, advertised on Craigslist is $1,000. That's the mean price for a one-bedroom apartment. Assume a population standard deviation of $200. Construct a 95% confidence interval. So to construct a confidence interval, we need the margin of error. And this is the formula that we use to calculate a margin of error. One thing I want to caution you about, in these problems, you'll be given a mean. That mean is not used in the calculation for a margin of error. It's not used until you go to construct your confidence interval. That's where the mean comes into play. That's where you add and subtract your margin of error from and to the mean. So we're going to calculate this. We're going to calculate a margin of error, which is denoted by the uppercase E, and our our Z value for 95% confidence is 1.96. So 1.96, and we're going to multiply that by our standard deviation, which is 200, and we're going to divide all that by the square root of our sample size. And in this example, 60 apartments were looked at for their prices, so that's our sample size. I'm just going to use this for square root. It's easier than trying to find the symbol, and that's going to give us our margin of error. I'm just going to do the math in Excel since I have it up. I'm just going to say equal 1.96, and I'm going to multiply that by 200, and that's going to be my numerator, which is 392, and I'm going to divide that by the square root of 60. And the square root of 60, I can use this formula, SQRT, in Excel. Just put my number in parentheses, and that's the square root of 60. So I need 392 divided by 7.746. We'll just go to 3 decimal places and round it. And that's going to be equal to 392 divided by, and I'll just use the whole thing here, and that gives me 50.61. So that is my margin of error, 50.61. Meaning I'm going to, I know that $1,000 plus and minus 50.61 is going to be the price for the population for a one-bedroom apartment 95% of the time. I just wanted to show you too, this is also in the PowerPoint. I did the calculation out here manually, but I can also use this formula confidence.norm in Excel. I'm just going to double click on that, and that is looking for alpha, which is 1 minus the confidence level that you're looking for. So in this case, it was 95%. Subtract that from 1, I get 0.05. Then it's looking for a standard deviation, which is 200. And then our size, which is 60. And I get 50.61 again as my margin of error. If you look, hold on one second. I just wanted to show you what I entered there to get that confidence.norm, 0.05, 200 standard deviation, and 60 is the sample size. And that gives us our margin of error. It does not give us our confidence interval, but it does give us our margin of error. which is 50.61, and then to construct your confidence interval, you simply subtract that from your mean and add it to your mean. So I'm going to take my mean, I'm going to subtract 50.61, and that gives me 94939. So that's the lower value in my confidence interval. And my upper value is just the 1,000 plus 5061, which gives me $1,000, $1,050.61. So with 95% confidence, I can say that the mean price of the one-bedroom apartments are going to be between these two values. Okay, let's go on to the next question. How large a sample, so we're looking for a sample size, how large a sample of one-bedroom apartments would be needed to estimate the population mean within plus or minus $50 with 90% confidence? So we're going to be using this formula here because we are looking for a sample size. We want to know how many apartments do we need to sample and determine their mean such that we are within $50 with 90% confidence. So n is equal to the z value for 90%, which is 1.645, just looking at the chart. And I'm multiplying that by the standard deviation, which is 200. And I'm dividing all that by E. Well, E, in this case, we're being given that within plus or minus $50. This example is telling me what it wants the margin of error to be. It doesn't know the sample size, but it wants the margin of error to be $50 within 90% confidence. So 50 is what I use for E here, and I'm raising all of that to the second power. So let's just do out the math, and that should give us our sample size. So we have equal 1.645, and I'm going to multiply that by 200 and divide that by 50, and I get 6.58, and now I'm just going to square that. I'm just going to multiply it by itself. It's just easier to do it that way, and I end up with 43.29 or 43.3 apartments I need to sample. Well, we're talking about a sample here. We're talking about a discrete number of things that we're going to do. So we're going to round this down or round it up. Well, 43.29 rounded just theoretically should be 43. But when you're talking about a sample size, you're always going to round up. We are going to err on the side of caution. And if we were literally going out and sampling apartment prices, instead of doing 43, we would do 44 just to be sure. It's always better to have a larger sample size. So in this case, our n value is going to be 44. Okay, the next problem. We are 95% confident that the interval 23.22 miles per gallon and 23.58 miles per gallon includes the true mean MPG of your vehicle. From this information, what was the mean from the sample and what was the margin of error? Well, if you think about how we construct a confidence interval, which we did right here, we constructed this by adding and subtracting the margin of error from the mean. The mean is the value that sits right in the middle. So in this example here, to find the mean or the mean from any confidence interval about the mean, is you're just looking for the midpoint between these two values, and that will give you the mean. So we just have to add 23.22 and 23.58 together and divide by 2, and that will give us our mean value, which is 23.4. So the 23.4 is right in the middle between these two numbers, and then to get to these two numbers, 23.22 and 23.58, we just subtracted the margin of error and added the margin of error. So we can determine the margin of error, for example, by subtracting 23.4 from 23.58 to see what value was added to 23.4 to get 23.58. So if I take 23.58 and I subtract 23.4, because that's the number in the middle, I get 0.18, and that's my margin of error. And you can see that by adding the margin of error to this mean, we get 23.58, which is our value here. And if we subtract 0.18 from 23.4, we get 23.22. So we're just working backwards versus working forward. So that's an example of 3 potential problems from this week's material. As always, reach out to me if you have any questions or concerns.